Hello, everyone. We're going to wait just a few more minutes to let people continue to join, and then we're going to go ahead and get started.
Doing this.
Okay, everyone, we're going to go ahead and get started. Thank you for joining us today for our product demonstration of connecting DeviceWISE to AWS IoT. If you have any questions during this product demonstration, there is a question and answers tab in a chat that we will be addressing these questions at the end of the presentation. So with that, I'll go ahead and pass the ball over to David De La Rosa for the demonstration.
Yeah, thank you. Good morning and good afternoon. Some of you are probably overseas. My name is David De La Rosa, and today we're gonna provide you a very quick overview of how our DeviceWISE platform can exchange messages with Amazon AWS IoT, also referred as Greengrass if it's run on premise. So good morning. So first of all, who is Telit? Telit is a spin-off, or was a spin-off from the IBM Industrial Group. We have 15 years of experience doing integration and automation, even before the Windows operating system existed. Many of the IBM plants and Fortune 500 plants were integrated using our software products at the time. So we have quite a bit of experience in shop floor integration to MES, ERP, quality systems, and more. In 2013, the Telit Corporation, an Italian company, acquired this division. Telit's strength is in connectivity and communications, particularly cellular radios, 3G, 4G, 5G, and more. Telit is in the business of connecting things from hardware and software. We have a product family geared specifically for semiconductor space called SecureWISE. This is what you see at the bottom. All 300 millimeter fab or plants or factories in the world run Telit's SecureWISE. The product that we will be discussing today is called DeviceWISE, which is used by many Fortune 500 companies to integrate production sensing equipment to many kinds of IT systems that are on-premise to cloud-based systems such as Amazon AWS IoT. Our presence, so we have a very, very strong presence in the automotive space. The top 7, we are installed and helping customers in the top 7 car makers in the world, as you could see. Numerous tier 1 suppliers that provide componentry to these car makers. DeviceWISE is also used in the pharmaceutical vertical, food and beverage, and in oil and gas sector. So pretty industry agnostic. DeviceWISE is, like I said before, is a pretty industry agnostic platform that facilitates solutions that integrate production control systems and IT systems, also cloud-based systems. Customers can very easily realize these solutions without the necessity or the need of custom programming at all. You could do applications such as OEE, predictive and preventive maintenance, exchanging information with MES, ERP, and of course, machine learning and artificial intelligence type of applications. So you could do all of those with this single platform. DeviceWISE is a software agent that can be installed on many operating system platforms, such as Windows, Windows servers, Linux on Intel, Linux on ARM, IBM AIX. Sometimes we also support installing in network appliances such as Cisco, industrial switches and routers, IoT gateways from Dell, Lenovo, Siemens, and others. It is also available in a containerized form, for example, Docker technology. So what does an unconnected factory look like today? Also a non-industry 4.0 factory. Silos of data, many custom code applications, or many custom point-to-point applications. It requires a very large IT staff. Making changes typically costs downtime. Scheduling is complicated, not very agile, and expensive to kind of update and retool. What does an IoT factory look like? Systems are connected to optimize cost and processes. The need, for example, a machine that needs calibration or service will automatically generate a support ticket directly to some system like Amazon has a system to do this, IBM Maximo, SAP PM. Some legacy systems may need to interact with like an Oracle database for quality maybe, or SAP ERP for procuring parts. So we could also exchange information in parallel for some artificial intelligence and machine learning system in AWS, for example. They may also need to provide production type displays dashboards for work instructions or simply OEE displays on the shop floor. DeviceWISE is the one platform where you can interconnect all these systems without any kind of custom code. An Industry 4.0 compliant factory is agile, and it optimizes the best of each OT system and the best of IT system all in one platform. So the Telit industrial IoT DeviceWISE platform. So with the one platform, there's many angles to this platform that we support that you're able to leverage. For example, in the top half, the connected machine. Machine builders can realize the new service remote support paradigm. The machine or the asset, like on the top left, may have multiple devices such as PLCs, and may need to send consumable or status fault information to some cloud-based system. So that would be from the left to directly to like AWS, for example. In addition to this path, machine builder can leverage our IoT platform to do over-the-air updates to the connected asset. For example, deliver new firmware, modify a PLC program, or just do application updates on the edge. That is the connected machine paradigm here. On the lower half, with DeviceWISE, the OEM such as a car maker or tier 1 supplier, can manage its factory. It can choreograph the flow of information between the shop floor and IT systems. Shop floor includes PLCs, torque tools, barcode scanners, RFID, and things like that. IT systems on-prem are like SAP ME, MII, IBM, Oracle, and many others. In addition to accessing on-premises IT systems, DeviceWISE allows you for bidirectional flow of information from your shop floor to application hosted on the cloud, for example, AWS, Microsoft Azure, MindSphere, and others. So basically one platform for the connected machine and the connected factory. DeviceWISE has many built-in IT connectors. DeviceWISE is also could be installed on the data center, can reach OT devices, but also any IT system on-premise or on the cloud. All adapters are built in and deployed when DeviceWISE is installed. So you do not need to touch your IT system. You do not need to make any modifications to your enterprise. Just install DeviceWISE and the plugins will do the discovery and the exchange of information. So the reason we are here is, of course, AWS. So how can customers leverage their shop floor investment with ready-to-go applications from AWS? DeviceWISE provides the information bidirectionally needed by AWS applications such as for remote management and OEE, asset condition monitoring, safety, alerting, anomaly detection and pattern analysis, predictive quality, and maintenance. So if you need information in any of these applications from AWS, we could put you in touch with your local AWS representative. So why all of this? Of course, digital transformation leads to valuable business outcomes. New service and business models for the machine builder, for the OEM, product improvements, customer satisfaction, increased efficiencies, of course, intelligent decision-making, and a data-driven discipline. No more guessing, no more magic. It's all based on the data. So let me see. So we are very close to begin a quick hands-on demo here, and what you see here is a preview of the Workbench. We have multiple connectors for cloud-based service connectors, but today we are going to focus, of course, in AWS. So what I'm going to do now, maybe take a small break for a second and make sure everybody can see my Workbench. Give it a couple of minutes. So what you see here is the Workbench. The Workbench is the application that is used to commission DeviceWISE, make all needed configuration, business flows. This is how you configure device connectivity and business logic, also called edge logic. All this logic runs on the gateway software. The gateway software is a software agent. It runs on Windows, like I mentioned before, Linuxes of many kinds, Red Hat, Ubuntu, Raspbian, IBM AIX. In some cases, it runs embedded in some of the PLCs, like Siemens, Rockwell, Mitsubishi. It's also available containerized. and can also be deployed in network appliances like Cisco industrial switches and routers. This icon here represents my laptop that I'm presenting from, but as you could see here, there's a few other ones that I can reach, Raspberry Pi, and a handful of other ones. But we're gonna stay right here on my laptop. So the OT layer is configured in what we call in DeviceWISE as devices. And we support multiple kinds of devices, right? So we support all kinds of torque tools from many vendors, Atlas, Copco. BACnet is a protocol used for facilities automation, Beckhoff, soft PLCs, more torque tools, DCS, that's for oil and gas. Fanuc CNCs is for tier 1 supplies that are machining, robots, more torque tools, all the Mitsubishi PLC line, all the Omron line, all the Rockwell line. SNMP is an interesting one because you could also hook to equipment that is SNMP enabled. Siemens, all the Siemens line, and many more devices. So we have a large collection of libraries, of drivers, sorry. Then I predefine some devices. For example, this system monitor device, let me mark it here, started, is basically looks at the vital signs of my laptop. It's only for illustration. Here you see the CPU usage, maybe the memory that is being used, the battery state, and you could read the values, or you could, let me see, memory usage, CPU usage, on battery, well, it's okay, watch. And now you have, if you notice, I'm connected to on AC. So basically, you see all the tags that are represented here in a tag tree. And this is the beginning of an IoT application. So I'm going to show you pretty quickly how to configure a Fanuc CNC 0IF. Let me see if this one is the one. Okay, let me do it from scratch. I'm going to call it Ansel new AWS Fanuc CNC. You pick the type, that would be 0IF. You put the IP address. In this case, I'm having to look at a document here, 27.9.99. You check that the connectivity is good. You save it, and you start it. And what happens is the DeviceWISE connected to the CNC and did all the introspection needed, and now you have access to all the IoT or process variable information inside that CNC. It's analogous to this system monitor. So we have access to all the process information inside that CNC. And what I'm going to do here is do a Rockwell one. And you pick the type. And again, you put the IP address, so you need to do. Notice it's very simple. Where is it? What's the slot number in this case? Again, you check, you save it, and then you press start. And what happens here is that DeviceWISE goes to that particular hardware, in this case a PLC, does introspection and retrieves the entire data model of that PLC. And now you have access to all the tags with all the types and everything. So this is the beginning of any industrial IoT application. And as you can imagine, we're going to get some of this data and eventually ship it to the AWS IoT infrastructure, or for some application like predictive maintenance or OEE. So in net is DeviceWISE has an extensive library of device or OT connectors. Because we have to run on many platforms, we do not rely on OPC technology to connect to these devices. All of our drivers are done bare to the metal and native. So that's why they run on Linux, on AIX, on Raspberry Pi, and the like. So very, very extensive set of connectors. So now we're going to briefly go to the AWS console here. And you could see that I was already sending some messages this morning. But basically, the configuration in on the AWS IoT part has to do with creating a thing, having the proper access roles, security, and it will generate all kinds of security information like certificates, private keys, and the like that we will need to commission the communication. So this is all is already done, so we don't have to do it all from scratch. So trust me, it's already happened. And then we're going to come back again to the DeviceWISE to show you how we move the data to AWS. So let me go back here. So the first step to talking to AWS IoT in DeviceWISE is to clearly configure the connection to the AWS IoT core or Greengrass if it's running on-premise. So what you see here, this is the information that is needed to onboard the DeviceWISE agent into AWS, the AWS infrastructure. This is the certificates, of course, and this is the client ID that was pre-configured in AWS. All this information you obtain from the AWS console. The private key is not configured at this moment to go to a TPM. I didn't have enough time to do it, but in production systems, this key goes inside TPM for obvious reasons, for security. But this is all that is needed. Download the certificates and store them in the proper places, and that is all that is needed. So let's define a simple problem statement here so that you could visualize the flow between DeviceWISE and AWS IoT. So what we're going to do is this is a hypothetical use, is that AWS has a system or an application that does predictive maintenance on laptops. I mean, I know it's hypothetically, but it should illustrate how we do this. So that system needs the vital signs of my laptop. For example, the CPU usage, the memory usage, network usage, battery discharge rate, on those sort of things. Of course, a real use could be a CNC or a torque tool or a press or some kind of process that when there is an anomaly detected, AWS then will do the proper signaling to correct or anticipate some not very good business outcomes, so they could react to it. But for the purposes of this illustration, we are going to use just my laptop. So for that, we will go back to our device that you saw before, and we're going to pick CPU usage, for example, memory usage, maybe the battery, right? So CPU usage here is very small, 8%, 9%, and so on. So we're gonna get this data, and we're going to send it to AWS IoT Core. Of course, I already did this, so I'm going to briefly show you how this runs. And then if you notice here, it's delivering already data to AWS IoT. It's already sent that much telemetry data. And if you look here, you begin to see, data arriving. And once you reach the IoT core, then the AWS magic of routing to the application that does preventive maintenance takes place, and then the business outcome takes place now. So let me move this. Well, let me see. Well, I guess I can move it. Okay, anyhow, so let me show you how this works. What you see here is what we call a trigger. This is basically what the rules engine or the edge logic is. Basically, what we have here is an event, which is at the top. You pick the event type, and then you put a set of logic down below here what to do. And what we did here is mapped. This is a small JSON document here that describes the data that AWS needs. Once you specify this, you map those key items, CPU here, to the actual CPU usage of my laptop. The memory, if you notice here, you map it to the memory use, the actual memory use of my laptop. So what's going to happen is when this trigger fires every second, then data is going to show up every second in AWS IoT core. But generically, let me show you I build you something a little bit from scratch here. And let's go over the events. So the event engine here is pretty powerful. So you could have an event is when the event is true, the business logic or the edge logic will run. So there's many kinds of event. There is an event like the one I showed you before, which is a cyclical event, fire every second, but you could also make it like a schedule. You could say, I wanted to fire it at the beginning of every month, in the middle of the month, and so on. So you could control when this runs, pretty granular scheduler. So this is the event that is time-based. Another kind of event is data-based. And what that means is we look in the OT space, let's just say the system monitor, and say CPU usage. And if it's greater than, say, 50%, do something, right? So this is a data-driven event. And clearly, we have to poll the device to determine the value to see if this event is true or not. So that's what we call events. And they're very, very powerful events here. For example, PLC logic events. This is when the OT device sends you a message. These kind of events are very efficient because you don't have to pull the devices and you could scale. One big server can easily talk to many, many devices, many PLCs, for example. So this is a different kind of event. There is another interesting event here. You noticed it probably that I went a little too quick. It's an AWS IoT Core event. And what that means is we could subscribe to a particular event. And what that means is when the business system on AWS wants to send the edge a signal, like turn off this compressor or light up this display with this information, then this trigger will run and then will take the appropriate action down below. So this is how the bidirectional with AWS IoT Core. So just for a quick demonstration here on the business logic part. Down here is where you do the business logic or the edge logic. So let's just say that I want to send an email to my boss every 2 seconds. So what I do is I'll go to the networking group and pick up email, drop it by, two seconds, and then of course fill in the credentials and the server address and what kind of security and what kind of authentication. But when this is already running, then my boss will know who I am every 2 seconds. So a simple preventive maintenance could be something like this. If some device says that, let me pick this one. Oh, that's a string. Let's just say that. Then we want to send an email. If it's equals to something, for example, it will send an email to some supervisor or our plant manager. So this is a very simple on-premise preventive maintenance application. So this is kind of how DeviceWISE in general can be used to implement OT to IT, and IT being, of course, on-premise, and it also means in the cloud, leveraging the services the AWS provides for customers. So at this point, I think this quick demo is complete. You see how easy it is to configure devices, how to just do a very simple transmission to AWS. I did fail to mention that the triggers are very rich. You could do if then else, you could do loops, you could do data filtering and reduction on the edge, and then only send significant business actionable data, right? Instead of sending a sample every so often, just send when the IT system needs to know. And on the left, you see that there is all kinds of capabilities, if then else. If you have, for example, OPC UA systems, you could, call methods to do things on the machine. We participate on, Active Directory and LDAP. If you want to leverage, then we could participate in that role-based security. Anyhow, so that's concludes the demonstration, and I guess I'm going to hand it to Kipli, and we could enter the Q&A section.
Thank you, David. There were a couple of questions that came through here. One of them was if the recording will be available after this call. Yes, it will be available and should be available through the link that you used to join this live event. We had some other questions here. Yes, you will be able to share the link within your organization, no problem. And then we have a question here from Brian from Electromatic, and it says, from a sales perspective, do you offer an on-site product/software demonstration on equipment to show how easy it is to set up? This demonstration isn't, he just wanted some more information in terms of the demonstration, and if we had like an on-site product or software demonstration for equipment to show this.
Well, actually, we can provide a trial product license that they could use. Of course, if it's going on site, that's a little different with this coronavirus discussion now. But you could download, we could provide him access to the product so that he could try and get familiar with this.
Okay, and then we have another question here. Event for a text file or a CSV file in a particular location gets appended. How do I read the latest entry into that file whenever a new line gets added into it? Is file property monitoring available?
Yeah, so we have a new extension. I don't have it installed here. Basically, the extension hooks into file system events. So you monitor a directory, for example, and then when a file is put on there, you will run, and then we'll give you the name of the file and so on. And then today you could import that. If it's a CSV, for example, you could import that into our local database, and then you could pick the latest records. There's a little bit of trigger logic that you would have to do, but yes, you could do it.
Okay, we have a next question here. If a PLC trigger gets activated every 1 millisecond, will it take the data and be able to read it? How many such signals can I trigger at every 1 millisecond?
I think the question is, how quickly can we poll the device? Is that what it is? So if the device or the PLC, for example, is turning on a bit and then turning it off and then turning it on and turning it off, the question I think is, how quickly can we read it? And if that is the case, so there's two parts to this question, I think. The first part is, how quickly can we read it? I could tell you that we read it dramatically faster than the traditional OPC servers that are out there, dramatically faster and more deterministic than the OPC servers that are out there. However, it is a sample system, and you will miss some of the transition. So that's the first half of the question, I believe. And just pure physics, there is a sampling rule that you have to obey, which is, I think, is 2 times the frequency. You could try that, but the perfect solution to this problem, so there is no ambiguity, is have the device send you the data when he knows you need to have it. When the flag goes high, send the data, and then as an unsolicited message, which was the PLC logic events that I mentioned. And in that case, you will not lose any data at all. And you gain, of course, you don't have to flood your network with polling for bits or anything like that. So in that case, you get data integrity. You always will get it, and you have the chance to have a guaranteed delivery. You know that it made it or that it didn't make it. So in the case that it didn't make it, you could point to another system that could act as a failover system. I hope that answers the question.
Okay, and then we have another question here. It looks like this one has a couple different parts to it, so I'll just read it part by part. So this one is also in relation to monitoring machines every 10 milliseconds. They're asking, is this setting available on the Workbench, and is there any limitations on how small the monitoring interval can be?
You could. So there's two. Yeah, well, even for those 2 parts, there is still, for the first part, you could read as fast as you can, but you still have latency issues. You still have some devices that do not like to be invoked so rapidly. They will discard your messages because their main business is control, not servicing this stuff outside. Again, polling a device has a lot of shortcomings, mainly a lot of CPU usage on the host computer that is polling it. And number 2, you cannot poll it fast enough. You will miss some times. If somebody goes to that server and runs a big query, the timings will change and you will miss a few. It's not for example, Windows is not as installed. It's typically not a real-time system. So you will miss cycles and you will miss signals. The best way is to have the machine or the device send you the data when you need to have it. We call this unsolicited messaging. I don't know how familiar, well, let's just assume it's Rockwell. You use an instruction called the message instruction. The PLC will deliver the data to you, and it gets buffered and it gets queued. So there's no data loss. If it's a Siemens PLC, there's many kinds of instructions, AG send, B send, T send, you name it. They have a lot of instructions. If it's Mitsubishi, I think it's buffer send. But it is the end device that is the master. He sends you the data when you need to have it. And then that, by definition, means you will never lose data because he gives it to you when you must have it. Like when a test result completes, for example, then you'll have it. What was the other part of that question?
So the next question, and these are all from one person. So is it possible to deploy the IoT portal on AWS? And will all the features which are available on using the Telit Cloud pay as you use model is available in private instances?
That's a great question. So yes, you could deploy it in a private instance. Also in AWS, actually our IoT portal, which is the data hub in the cloud for our service, is deployed in AWS. There are some companies that deploy it internally on their data center. So yes, that is possible.
Okay, and then another question associated with that, does private instance support multi-tenancy, or will I need to deploy the solution individually for each customer site?
I think when you install it, the idea is the multi-tenant. Think about a mobile network operator like AT&T or one of those. They will provide multiple tenants. So by definition, the IoT platform is built for multi-tenancy.
Okay, and then will it be a major effort to deploy the platform on AWS, or are there some guidelines available regarding the infrastructure required, services used, scaling? Is it something which can be achieved in a couple of weeks?
You know, to be honest with you, I cannot answer that question. That is not my area of expertise. I know that not a simple system. It has all kinds of redundancy, multiple virtual machines, and so I couldn't answer that question. I assume it's not like a setup and go. I think it's you probably need to hire Telit to help you deploy it and even manage it, I think. But we'll find out the answer for that and then let him know.
Perfect. And then we have a couple more questions here. How can we add additional custom-made functions? Any ODK or easier methods?
Additional functions to our palette of functions? Yeah, so let's assume that's the question. So there's a variety of ways to do this. The first one is there is a scripting language built in DeviceWISE that you could use. So you could express some kind of logic using a language called Lua. Where in the world is it? Lua scripting. Where are you? There you go. So you could deploy, you could write Lua scripts, you know, so Lua is like a language, so you could develop some script to do something and then inject it right here. So now that logic that you develop in Lua is now available in to DeviceWISE. Now there is another way to do it is we have an SDK and you could provide your own native functions and they will be deployed here. You will see them here. That's a little more complex. You need to have an ANSI C type of programmer, but you could do it. So the SDK is available and you could develop your own functions. I could tell you that there is a lot of roadmap discussions about running things that are written in Python. So that will come much later in this year, I'm hoping. So you could do Python code, which is typically used for machine learning, TensorFlow, that kind of stuff. It's not done yet, but actually we haven't started. But that will happen because a lot of machine learning models can get deployed on the edge. So, but that's much later. So you have the SDK, you have Lua, and possibly in the future Python code.
Perfect. And then we have a question here. How many PLCs can DeviceWISE connect to simultaneously?
Okay, that's a good question. And then if you poll those PLCs, then the number of PLCs is a function of how aggressive the polling is. If you poll, say, X number of tags every 30 seconds, you could probably connect to 60 PLCs, no problem. If you use the unsolicited method that I described before, then you could probably connect a couple of hundred. Our large customers, Fortune 500 companies, they have 200 torque tools, 180 CNCs, you know, 100 and something PLCs on their assembly line sending data all the time. They all use the unsolicited method because of the scale. You could scale. Without doing this, you will have to spin up more compute to be able to handle the throughput. But if it's you pull a few tags every 1 minute, yeah, you could probably do 100. But if you need a couple of hundred tags every 3 seconds or 5 seconds, then you'll be able to effectively do less because there's not enough capacity in the compute network combination.
Okay, and then the next question we have, does it support Fanuc CNC controller?
Yes, we support Fanuc CNC controls that are Ethernet based, all kinds, all of them. So we support, of course, you know, multi-access, all that stuff. And I think I may have shown a little bit of it here. Let me see. And then a couple of features, also multipath and also unsolicited. And again, unsolicited is here it's a Fanuc CNC. So you see everything that is supported here. PMC is the control area. So we support the Fanuc CNC completely. We have all of them that have Ethernet. We support multi-axis, multi-spindle, tool offsets, which is used for like CMM adjusting in manufacturing, and then unsolicited messaging, which is very good for machine learning and analytics because you could see the current consumption through time, and then you could infer the mechanical wear for predictive maintenance. So we do support all the Fanuc CNCs. Now there are some CNCs that are that support MT Connect. It's kind of like the OPC of machines, CNCs. We also have an MT Connect a driver, so you point to a URL, set up a couple of parameters, and now you have the entire MT Connect model CNC like a variable, like you see here right now on the Workbench. So more than just Fanuc. Any machine that has MT Connect plus Fanuc, some versions of Siemens Cinemeric we also support. Some newer machines that have OPC UA service built in, like Siemens ones, we also support. We have a UA client, so good coverage on CNC.
Perfect. And then the next question here, does it support logging of data locally?
So DeviceWISE has an onboard relational database. You see it here. And this is where you could do, data reduction, a little bit of filtering before you send it to a higher level system. So it does have a disk-based tables and in-memory tables. The in-memory tables, of course, are used to when you get when there is a lot of data streaming from devices, we pump it into those in-memory tables, do like standard deviation, whatever that needs to happen exceedingly fast, and then we talk to an IT system. So it has disk tables, in-memory tables. You could do inserts, you could do deletes, you could do aggregates, everything except store procedures you could do on this table. So the answer is yes and more.
Perfect. And then can you connect to both AWS IoT Greengrass Core and MQTT Broker on-prem and AWS IoT Core on the AWS cloud?
Yes, both of them are supported. We have customers that are trying Greengrass on-premise and customers that are doing straight to the cloud.
Perfect. And then we have another question here. Is a local database a persistent database or an in-memory database? It's
both. You have an option to define a table that is in memory or in disk. Right here is a disk persisted, and here is a in memory.
And then we have another question here. How do you add additional device drives for different devices, PLCs, that are not there as standards?
Okay, so we do have in excess of 100 and some drivers already. I have installed a subset here. This is what you see here. So if we don't have the particular driver, some devices don't really need a driver. There are some machines that have a RESTful interface. So you could use one of our IT connectors to fetch data from it, for example. If you need to do a very high performance driver for some device, then we provide the same SDK, and then you could do the driver, or we could do it on your behalf for a fee, of course. And then that's how you would do it. The SDK way is the best way. And when Telit is commissioned to do it, then it's available in all platforms: Windows, Linux, Raspberry Pi, IBM and AIX, Rockwell Compute modules. We make it available in all platforms. So just to reiterate, some devices are simple, like a weighing scale. It could be simple TCP, simple serial. We have extensions that you could leverage to read simple things, so you might not need a driver. Some have RESTful interface. We have a RESTful connector, so you could post something or do a get and get some data. Or the ideal for speed and scale is to do a full-blown driver, native driver, and then you will leverage the SDK. And then once you have the SDK, you could add the driver like a plugin. So just as simple as add, pick the file, and now the driver becomes available here on this palette of drivers. Perfect.
And then we have another question here. Unsolicited data buffering happens at the edge or at the PLC?
There is various points when this happens. So if you have, let's just say, I'm not picking on Rockwell, but there's plenty of Rockwell here. When the instruction fires, it gets initially buffered on their communications module. Then when it's sent out on the wire, it gets buffered on the TCP/IP stack of the end computer where we are running, and then it gets to us. So there is plenty of buffering in between. So it's buffered in various places through time, of course. It buffered first on the communications adapter of the source, and then it gets buffered on the stack on the receiving computer, and then we get it.
Very good. And then I have a couple other questions here related back to the Fanuc. Is the Fanuc interface capable of both read and write functions? And then somebody else had a question of what if the Fanuc controller has serial only?
That's a good question. So all of our drivers support the concept of reading and writing. However, writing is a very dangerous operation. So DeviceWISE has a role-based security system. So you create roles and groups and users, and you could allow everybody to read, but only a selected group to write. And again, if you hook this to your LDAP or Active Directory, and then it's managed at the corporate level. So they create the policies, and DeviceWISE enforces those policies. There are things that are read-only, of course. So when you try to read them, you get a failure. It says read-only. There are some things that are writable that you don't have access to. Will also let you. But in general, you could read and you could write. Not quite everything, depends on the device. But yes, we could do reads and writes, as you could see. For example, in the PMC, you could go here, pick a register, and then you could do read or you could do write. Right. What was the other question? Sorry, I missed it.
The second question is, what if the Fanuc controller has serial only?
Okay. So the Fanuc controllers have Ethernet usually. Now, legacy controllers have a serial, a very traditional serial, or they have a fiber optic serial that is called HSSB. It's typically used in very RF intensive environments, which is what happens on machining. We don't support yet this HSSB. We could, if there is a customer demand. It's not difficult for us to do the way we're doing this driver. So yes, we could support HSSB, but we don't have it at this moment.
Okay, and then does DeviceWISE support REST API?
Yes, you could do it at various levels. Yes, we support post, get, with security certificates and everything. Yes, it is supported. It's right here.
And then somebody also asked, is the DeviceWISE a REST server too?
So here's the RESTful. DeviceWISE could be the recipient of HTTP kind of transmissions, yes. There is a trigger event that is called the page listener. We will turn on our own HTTP server, which it's here, somewhere here. I started, listening on those ports and so on. So now you could send post and gets to it, and then handle it on the triggers. Everything is done on the triggers. So for example, you could create a page listener event. I think that comes in the networking part. HTTP page listener. And then what is it, a get or a post, or, and then you could do your business logic or edge logic here. Yes, so you could do it.
Perfect. And then we just have time for a couple other questions. One of the questions here was what time variables can be read?
Time variables, like timestamp data types. If that's the case, some PLCs have multiple types, integers, floating point, or real, the column. They also have timestamp, right? And depending on the PLC, we may support it, we may not. It's device specific. Generally, we do try to support all the types. So if there is a timestamp on a device, and let's just say it's a highly BCD encoded one, when we read it, we'll do the conversion to be a GMT, 8-byte kind of timestamp. You don't have to do any math in it. That's in the Siemens case. That's usually what happens. It's very encoded, particularly the legacy PLCs.
Perfect. And then we have another question here. What Lua version is used in DeviceWISE? And if I can download Lua modules by myself or Telit needs to do it?
You could, I don't know the version offhand. I'll have to find out. So make sure you know who this person is and we'll send in the information. But yes, you could include some modules. I know some customers that have included XML parsers and do parsing and things. So the answer is yes. I am not very familiar with it, but I know it's being done. I've seen it.
Very good. And then we have another question here. Can DeviceWISE act as an MQTT broker?
Yes. So it could act also. Yes. The answer is yes. And I might not have it. Oh, no. Sorry. DeviceWISE could publish on a topic to a broker, and it could subscribe to a topic, but we are not a broker. So you would have to install an external broker like Mosquito or any of the other ones, and then we could exchange, we could pub up to it. Sorry.
Okay, and then we have another question here. Which in-memory database is DeviceWISE using?
We use SQlite.
Perfect. And then do you support Keyence PLC?
Not at this time.
Okay. And I think it looks like that's all the questions that we have here. And we're just about at the time anyway. So with that, I'll just let everybody know, again, if you want to review this recording after, it will be available through the link that you used to join. If you have any problems or any questions relating to the live event, I went ahead and I published my email so everybody has it available. Go ahead and feel free to email me any questions or inquiries that you have, and I can make sure that they get to the correct people. So with that, David, thank you so much. We appreciate your product demonstration, and we hope that everybody has a great day. Thank you.
Thank you. Bye.